Surprise twist in the lineup, everyone. Episode 16 of our NEET chemistry series just dropped, and this time we're diving deep into the quantum core atomic structure. I'm Chongtham David, your mentor, and with just 15 days left for NEET 2025, it's time to break down atoms before we break through the exam. We'll solve 45 laser focused questions covering quantum numbers, electronic configurations, and the hydrogen spectrum, the kind of stuff NEET loves to test. Here's a thought to energize your prep. Even the tiniest particle holds immense power, just like your daily efforts. Stay sharp, stay curious, and let's build a clear picture of the atom, one question at a time. Ready to orbit the success? Let's jump in. Now, without any further ado, I'm going to start sharing the screen for you. Let us read the first question. Among the following groupings, which represents the collection of isoelectronic species, you're given here different types of ions. So out of these given ions, you should choose the collection of isoelectronic species, meaning the same number of electrons. So the species, this carbonyl, NO plus, Cn minus, and C2 plus, they contain 14 electrons each. So C would be the answer because they all have 14 electron system. As for example, you can find the atomic number of carbon is 6, and hence it corresponds to 6 electrons, and for this oxygen it has 8. So in the combination process you have 14 electrons. So similarly, you find out for NO plus, you will be getting 14, cyanide 14, and carbide also 14 electrons. So question number 1, C would be the answer to this question. I hope it is clear. Moving on to the next question. Rutherford experiment which established the nuclear model of the atom used a beam of, he used doubly charged helium particle, that is alpha particle, as the atom. The model of the atom, he used a beam of doubly charged alpha particles. So helium nuclei which impinge on a metal foil and got scattered. So option D will be the answer for question number 2. He was a student of Thomson. Question number 3. Which of the following levels of hydrogen and helium ion have same energy respectively? So this was given by scientist named Bohr. The energy can be related as minus 2.18. This is your Ribel constant for hydrogen atom into 10 to the power minus 18 Z square by N square H. In NEET exam, Bohr's postulates becomes very important. So pay attention to this as postulates. Now if you solve this by substitution, minus 18, because the atomic number is 1, N square for hydrogen is 1, but you have the isoelectronic species helium. So what about helium? This is for hydrogen. We have to find for isoelectronic species of hydrogen, that is helium plus. If I take this ion, we can find the energy by using this energy relation as given by Bohr, Z square by N square. That is, this N square is the number of orbits for hydrogen helium, and by substitution you get 2.18 10 to the power minus 18 into 4, because the atomic number is 2. 2 square is 4, and now we have N square, that is the orbit for helium ion. So you can compare these two because the energy should be same as per the question. It says same energy. So by comparison, you have this energy of hydrogen equivalence with energy of helium plus. Now if I relate this, the only thing that is going to be left would be all these things, these constants are all cancelled, and what is left would be your 1 by N square for hydrogen and 1 by N square for helium. So this is equals to, or implies, helium plus would be 2 times that of the orbit in the hydrogen. So if I consider the hydrogen, the orbit is, let us say, if this is the case, okay, if NH is considered as 1, the helium ion would be 2, right? From this relation, you can easily deduce. And if NH is equals to 2, you can say that helium plus would be in the fourth cell and so forth. If I then take the hydrogen as the orbit in the hydrogen is 3, helium would be in the square of 4 would, sorry, 3. If I take 3, the square of 3 would be not squared, the multiplication of 3 into 2 would be 6. So now you have these values. So uh, respectively, right? So we can conclude that 1 and 2, this is correct, A is correct, and 3 and 4, this is not correct because you can relate this, right? 1 and 2, option A is correct, and you have this 2 and 3. Can I say 2 and 3? This would be 4, okay? 2 and 4, yes, this can be true. If I say 3 and 6, we have just proof that these are the correct pairs. So A, C, and D corresponds to option D. So question number 3 answer would be D. I hope it is understood, right? Let's read question number 4. A 600 watt mercury lamp emits monochromatic radiation of wavelength, only one wavelength of 331.3 nanometer. How many photons are emitted from the lamp per second? You have Planck's constant 6.626 into 10 to the power minus 34 joule second. Velocity of light 3 into 10 to the power 8 meter per second. So you know from Einstein's law or Planck's quantization that E equals to delta E, you can say it is equals to hc by lambda. This is Planck's quantum theory. You know the value of Planck's constant 6.626 into 10 to the power minus 34 joule second. And 3 into this is the speed of light meter per second. Unit later on you can write it down. Divided by wavelength would be 331.13 into minus 9. Clear? So this is the nano means minus 9, right? So simplify this. Approximately you can cancel this 2 and this would give rise to approximately 6. And when you take all these numbers, minus 34 minus 9, reduced to approximately minus 25 and 8, 19, right? So 6 into 10 to the power minus 19 joule. Now that you have the energy, what about number of photons emitted per second? You have to divide by this number to that of the given watt, that is 600. So photon is the packet of energy of light, right? Or quanta in the case of energy, photon in the case of light. Now let us calculate the number of photons that is going to be emitted per second in 1 second. So it would be 600 divided by 6 into 10 to the power minus 19. Comes in the numerator. 6 and 6 get cancelled. You go operation with these powers of 10. This is giving you 10 to the power 21 is the answer to question number 4, option C. I hope it's clear. Let's read question number 5. Energy of an electron is given by, okay, E equals to minus 2.178 10 to the power minus 8. This is according to your Bohr's postulate. And the wavelength of light required to excite an electron in a hydrogen atom from level 1 to level 2 will be. So consider the relationship delta E equals to 2.178 into 10 to the power minus 18. Now you can take 1 by, if I consider this as principal quantum number 1 to 2, it jumps. So it gives you 1 by 2 square. This is square, okay, not 12. Okay, then this must be equals according to Planck's quantum theory, hc by lambda. Now simply substitute the values of energy, or 2.178 into 10 to the power minus 18. For simplicity's sake, I'm just writing 2.17, right? 3 by 4. This is the required value you have by far. So which is equals to hc by lambda. Okay. So what is the value of Planck's quantum theory? Constant 626 10 to the power minus 34 into what is the speed of light? 3 into 10 to the power 8. You know this, right? And what is the given wavelength? Wavelength given to you is, right, it's given as, it's not given. You're supposed to find this lambda. So let me simply write here lambda. Now from this relationship, now you can find out lambda. I'll write it at the bottom. Lambda is equals to 6.26 into 10 to the power minus 34 into 3 into, this is the speed of light in meter per second, divide by this multiplication. You have already got the energy in the first expression, that is minus 8. And rationalize this, you get 3 by 4, which turns to be 4 by 3. And simplify this. You can cancel this approximately by 3. 3.3 into 3 into 4. 4 3 is 12. So approximately 1.212. So simplify this, 10 to the power minus. So how much it will become? 34 and 18. It is approximately 16. And then it further reduces to minus. If you add again, 8, subtract it, it is further reduced to 8. And now you have to multiply with this. You have approximately 1.2 into 10 to the power minus 7 meter. So where do you find this? The closest answer we find in option A. So 5 corresponds to option A. This is the answer to question number 5. Let's read question number 6. The energy required to break 1 mole of chlorine-chlorine bonds in chlorine molecule is 242 kilojoule per mole. The lowest wavelength of light capable of breaking a single chlorine-chlorine bond is. So energy required to break 1 mole of this chlorine-chlorine bonds in chlorine molecule can be written as energy equals to hc by lambda. So multiple questions are asked in the NEET exam based on Planck's quantum theory. It may sound simple, but questions can come from this section as well. So this energy I can relate as hc by lambda. 242 into 10 to the power 3. This much amount of kilojoule is required per mole. Okay, that is the Avogadro's number. You have to multiply and divide by this, which is equals to hc by lambda. What is the value of Planck's constant? You already knew that it is 6.6 10 to the power minus 34. Then speed of light, you know that is 3 into 10 to the power 8. Then what is the wavelength of light? It is not given in the question. So you are supposed to find this. You relate this to equation and you can simply get the answer. Lambda is equals to, now if I transpose the left hand side and the right hand side, so as to get the unknown variable, that is lambda, I can simply multiply this. Now speed of light is 3 into 10 to the power 8 meter per second. And now you can multiply this. This Avogadro's number can come up here because you're undergoing cross multiplication. I hope this is clear. Now by simply undergoing this simple mathematical operation, you can get the answer. But you need to do a lot of calculations, right? So let us simplify this. What is this? 8 and 23. 23, it comes out to be approximately 31. So this minus 34 is reduced to minus 3. And then when this comes in the numerator, this minus 3 and minus 23 becomes minus 26, right? So the value keeps on decreasing. But then you have to again multiply with this 3. How can you check the multiplicability of this number by 3? 6 plus 8, this is not multiplicable, but you can cancel this with 2, right? So 3.313. Multiply this again with 3. Approximately 9. This you have 121. 9 divided by 121 would be a very small number. Approximately it gives about 0.499. So let us say equals to 0.49, let's say 10 to the power minus the powers of 10 is already minus 6. So in terms of nanometer, you can simply further multiply this. 490 10 to the power minus 9. So this is approximately 490 nanometer, which is very close to option D. So D would be the answer for question number 6. Quite lengthy, but you need to solve this. Question number 7. The first emission line in the atomic spectrum of hydrogen in the Balmer series appears at. So for the Balmer series, the sequence was Lyman, Balmer, Pascal, Brackett, Fun, and Humphrey in the far infrared. So Balmer falls in the visible UV visible spectrum in the electrochemical. Sorry, the what's the sequence? That sequence is cosmic. Starts from cosmic, gamma, X-ray, UV, violet, indigo, blue, green, yellow, orange, red. Right. So this series you need to learn by microwave, radio wave. So this Balmer will fall in this bigger region, and IR, this will be the region where Pascal, Brackett, Fun, and Humphrey falls. UV is in the it is for Lyman series. Anyway, the question is based on the Balmer series, which means it jumps to the second state of the energy cells. So for Balmer series, N1, this is especially for Balmer, okay? For Balmer, N1 should be 2, and let us say the first emission line corresponds to N2 equals to 3. It jumps from 3 to 2. It cannot jump from 2 to 2. It has to jump from a little higher energy level. So this is the first emission line, not the absorption line. So N2 must be 3. What is this wave number? It is the number of wavelength in 1 meter length, right? So anyway, wave number can now be related by this Rybak's equation. I'm going to simplify this as 1 by 2 square and 3 square, which gives your 5 by 36 Rybak constant in centimeter inverse. This is wave number. So the answer for question number C would be 7 would be option D. Right, moving on to the next question, number 8. Let's read fast. Which one of the following set of quantum number is not possible for 4p electron? See, for 4p, you have the principal quantum number 4, and the azimuthal quantum number is p. And now we can say that n equals to 4, L equals to p means 1. Then your orientation has minus 1, 0. This is your magnetic quantum number, and spin can have two designated numbers in the clockwise plus half and in the anti-clockwise minus half. So looking at these values, you cannot have this option C as the correct answer. So this is not the possible for p 4p electrons. How can this have 2 as the magnetic quantum numbers, right? There is no possibility of having 2 in the magnetic quantum number. So C is the answer to question number 8. Moving on to the next question, number 9. What will be the difference between the electromagnetic radiation between is shown in A and B respectively? So this electromagnetic wave shown in this figure A has higher wavelength in comparison to electromagnetic waves shown in figure B. Thus, these waves also differ in frequency and energy. And it is written by the relationship nu equals to C by lambda, that is frequency is inversely proportional to wavelength. Okay, so this is the distance, which we call it the distance between two crests, or the trough is taken as wavelength. Let us say this is wavelength 1, and this is wavelength 2. So if I further write this as energy, E equals to hc by lambda 1. And in the second case, you have E2 equals to hc by lambda 2. But this lambda 1 is much greater than lambda 2 because of the larger distance. It is evident from the graph. So we can conclude that since it is an inversely proportional relationship, E1 cannot be greater than E2. It should be less than E2. So the answer for question number 9 would be, okay, 2 is correct, wavelength, 3 is correct, and 4 is also correct. It cannot be the relationship. The difference cannot be the relationship for velocity. So C is the answer. Moving on to the next question, number 10. It's the Manchester column type. So for this 4D subcell, the number of orbitals would be 5, and the azimuthal quantum number L would be 2, because it is in the D subcell, 0, 1, 2. It corresponds to SPDF, right? So for F subcell, you have number of orbitals would be 7, L equals to 3, and S subcell would be number of orbitals equals to 1, L equals to 0. P subcell, number of orbitals would be 3, and L equals to 1. So looking at this, you have this relationship. I'm going to match this relation with A. That is, A should be Q, and this should be again matched with 1, right? Then then B, F would now be linked with O, BS, where is number of orbitals. So the correct matching would be number of orbitals would be AQ1, AR1, AR2, BS4, CP3, DQ1. So A is the answer for question number 10. You have to match this correctly. I'll repeat again. Number of orbitals for D is 5, right? And it has angular D. And this B, F would be, carefully match this, S, and S corresponds to 4 because why I'm writing it S, P, D, F, 0, 1, 2, 3. Okay, these are the values of this L. Then what about C? It would be P because S has only one orbital, and CP3. Okay, P would be 3 and corresponds to 1. So A would be R, AR2, BS4, CP3, DQ1 would be the answer. So option A is the correct combination. Clear. Let us read question number 11. The orbital angular momentum for an electron revolving in, this is incomplete. Let us read question number 12. The energy of a photon is given as delta E by atom, that is 3.303 into 10 to the power minus 19 joule per atom. What is the wavelength of the photon that is given here in the options? You can calculate this by using the relationship delta E equals to h nu, so hc by lambda. Now we have lambda equals to hc by delta E. So how does it correspond? 6.6 10 to the power minus 34 into the speed of light is 3 into 10 to the power 8 divided by 3.03 10 to the power minus 19. To simplify this, you will get the answer. Let us calculate this. 3, you have approximately 2.2 minus 19. 2.2 into 3 would be approximately 6.6. Right, so it must be in the range of 600 something, 656 nanometer. Corresponds to option B. So 12, the answer would be B. Question number 13. The electrons identified by the 4 quantum numbers are given. You can place this in order of increasing energy from lowest to the highest. So how can you arrange this? By obeying the n plus L rule. So according to the n plus L rule, you have this n equals to 1 for L plus 1. So if I obey n plus L, the value is 5, 4, 5, and this is 4. To do the ranking based on the priority of the principal quantum number, you will be getting 4, 2, then 3, followed by 1. So answer would be A. Let's see the next question. For Balmer series in the spectrum of hydrogen atom, the wave number of each line is given by this relationship, that is Rydberg equation. Which of the following statements are correct? The question is given. So beyond a certain wavelength, the line spectrum becomes a band spectrum. This is correct. And for this Balmer series N1 equals to 2, this is correct. And option number 3, the ionization energy of hydrogen can be calculated from the wave number of this line. This is not correct. The line of longest wavelength corresponds to N2 equal to 3. This is also correct. So if 1, 2, and 4 are correct, the answer would be C, 1, 2, and 4. Moving on to the next question, question number 15. It says the wavelength of second line in the Lyman series of hydrogen spectrum is, Rybak constant is given as R. So formula of Rybak, you have to use Rybak formula, which is given as wave number equals to 1 by lambda equals to Rybak constant for hydrogen 1 by n1 square minus 1 by n2 square. And this for second line in the Lyman series, n2 equals to 3. So 1 by lambda would be Rybak constant for hydrogen 1 by 1 square minus 1 by 3 square. So the answer would be 1 by 1 minus 1 by 9, 8RH by 9. So A would be the answer for question number 15. I hope it is clear by far. Question number 16. If lambda naught and lambda be the threshold for wavelength and wavelength of incident light, the velocity of a photoelectron ejected from the metal surface is. So this is a question from the photoelectric effect. According to the relationship E equals to E naught plus the work function and kinetic energy. And this frequency is related as speed by lambda. Now if I rewrite this equation in terms of wavelength, it becomes hc naught, hc by lambda naught plus half mv square. Now how would you find this half mv square? It can be rewritten as half mv square equals to hc by lambda plus hc by lambda naught. This is h. Okay. So figure out this by taking out the common here. You have lambda naught. Wait, here you have to write your minus. To be minus. Lambda naught minus lambda by lambda into lambda naught. So you can easily get the answer by removing this velocity square. This velocity square will become v square will become 2hc by mass. That is lambda naught minus lambda into lambda naught. So from this equation, you take the square root, becomes 2hc by m lambda naught minus lambda by lambda into lambda naught. So when you compare this relation, the velocity would be, okay, option C would be the answer for this question because it is the same expression. Question number 17. If a wavelength of photon is 2.2 into 10 to the power minus 11 and this Planck's constant is given, the momentum of the photon is, so according to the de Broglie wavelength, momentum can now be related as h by lambda because what the question is asking is momentum, and now we have this Planck's constant. Substitute this value simply, divide by the value of momentum, you have minus 11. It will give you approximately, cancel this, can be cancelled by 3, right? So 10 to the power minus 23, easy equation. 17, answer would be 3 into 10 to the power minus 23 kg per second. Moving on to the next question, number 18. Which of the following set of quantum numbers belongs to the highest energy? So the atomic orbitals are 4s, 3s, 3p, and 3d. So according to above principle of n plus L rule, the values now becomes this. Just verify, it becomes 4, n plus L will be 4. This would be 3. I hope it's logically clear. 4, and this becomes 5. So 4, 3, 4, 5 would be, the highest energy would be option D, right? Because this 3D has the highest energy. Let's read question number 19. From the data given below, A, B, C, and D respectively are, okay, let us verify which is the correct answer. There are 10 electrons in the atomic number 11, which means this is a sodium. Okay. There are 10 electrons in atomic number 6. Atomic number 6. Just verify. atomic number there 10. So on atomic number 6, you have to check carbon, and if negative sign is there, you have to add. So this is correct again. There are 10 electrons in the atomic number 10. This is neon, which is true. And 10 electrons in the atomic number 9. Okay. 10 electrons in the atomic number 9 means you have to add one more electron to this fluorine. So the correct combination is sodium. This is true. Question number 19, answer would be option A. Now suppose a beam containing all three fundamental subatomic particles are allowed to pass through electric field. This is done by the deflection experiment by Thomson. He was analyzing deflection value and comes out to the value of charge by mass of ratio of electron. From that value given by Thomson and the oil drop experiment, we can easily come to the conclusion that the mass of electron was 9.1 10 to the power minus 31 kilograms. Anyway, so since these electrons are negatively charged particles, they got deflected toward the positively charged electron, whereas the proton being positively charged will get deflected towards the negative electron. So these neutrons, they are neutral in nature, so they went straight. So the answer for this question would be electrons for A, neutrons for the B because it went straight, and protons for C because minus and proton will be attracted, but then positive and electron will be attracted. Neutral particle, which is neutron, discovered by James Chadwick in 1932, right? So these are the fundamental subatomic particles. Remember this. For a d electron, the orbital angular momentum is, the expression for this angular orbital angular momentum is given by root over L plus 1 h pi twice pi. So for d orbital, the azimuthal quantum number L is equals to 2. So what is the value of this angular momentum? Root over 2, 2 plus 1 h by twice pi. Now if you simplify this, 3 to the 6, the answer would be root over 6 h by twice pi. Option A is the answer for question 21. Question 22, the uncertainty. This is from Heisenberg uncertainty principle. The position of an electron moving with a velocity of v is given. Then uncertainty is given in terms of percentage as 0.011 percentage. So remember the Heisenberg uncertainty principle, which states that you cannot easily predict the momentum and the position simultaneously for subatomic particles. Now for delta x, now since mass is constant, I can write this as h by 4 pi. You are asked to find this delta v, 0.011 divided by 100. This because this is in terms of percentage. I have converted this in terms of percentage. 3 into 10 to the power 4. Simply cancel this. You will be getting 3.3 centimeter inverse. So what is the answer for this question? It would be option. Okay, we haven't finished calculation. The question is asking the uncertainty in the position, right? Not this velocity. Okay, one more step, which means delta x can be now written as 6.6 Planck's constant minus 34 divided by 4 into 3.14 into 9.1 10 to the power minus, this is in grams. So the value would be 4 3 12, 12 9, and multiply with this 6.6 be 0.175. Answer would be C, 0.175. Clear? Question number 23. Let's read. The values of Planck's constant is 6.6 10 to the power minus 34 joule second. The velocity of light is 3 into 10 to the power 8 meter per second, which value is closest to the wavelength in nanometers of a quantum of light with the frequency of 8 into 10 to the power 15 second inverse. So obey this Planck's quantum theory. It states energy equals to h nu, right? So from this, you can simply get that 8 and this h nu can be further simplified as lambda. You're given 8 into 1 second, it's not 8. Should calculate here. Okay, 8 into 10 to the power 15. This is energy and speed of light 3 into 10 to the power 8 divided by wavelength. So easily you can calculate wavelength from this equation. Now it becomes 3.7, say 37.5 into 10 to the power 9, which is roughly 4 into 10 to the power 1, let's say nanometer, because you can simplify this to get the nanometer value. In terms of nanometer, it will be option B. Moving on to question number 24. The wavelength associated with a golf ball weighing 200 grams moving with a speed of 5 meters per second per hour is the order of. So use the de Broglie relation, which is lambda equals to h by p. You know, p is momentum, linear momentum. Then velocity can now be written as 560 into 60. Right, and then from this equation again, you substitute here. I'll write it here, lambda equals to 6.6, 10 to the power minus 34. This is your h. And mv. Multiply this value, you should be getting the answer. And you need to convert this in terms of minute. So multiply, don't forget to multiply with 60. Okay, 2.6 gets us to 36, 3,600, cancel the 2 zeros, and 5.6. So roughly you would be getting 2 into 10 to the power minus 10. So the order would be minus 10. So option A is the answer for question number 24. Question number 25, let's read. Given the abundance of isotopes, iron are 5%, 90%, 5% respectively, what is the atomic mass of iron? So you can find the relation from the average atomic mass of iron. So what is the average atomic mass of iron? It would be 54 into 5, 56 into 90, and 57 into 5. This is the relative abundance. So 54 into 5 would be 270 plus 56 into 90. Multiply, and after that you would be getting to 500. Okay, 55 approximate value. So 55.95 is the answer for question number 25B. So you should be getting 55.95. Let us see question number 26. Based on the equation given here, which is from the Rybrook formula, the wavelength of the light that must be absorbed to excite the hydrogen from level 1 to level 2 will be given your Planck constant and the value of speed of light c. This should be small c, okay? Now, you calculate this, minus 2, 10 to the power minus 18. This is given 2 square minus 1 square. Okay. So what you will be getting is 2 into 10 to the power minus, after LCM is taken, minus 3 by 4. You'll be getting, see this is what? 0.7, right? So 1.5 into 10 to the power minus 18. This is the value now. That is delta E. But according to Planck's quantum theory, you have lambda equals to hc by delta E. Simply substitute the value here. Okay. If possible, learn to by heart this value. That will be very helpful in the exam. 10 to the power minus 34, speed of light, and whatever value we have got as energy. So 1.5 and 1.6, this can be cancelled by 3, right? 2.2 and 0.5, 3, you can cancel this. Then roughly 1.3, then the power minus 7. The answer is very close to option A. So 26, option A is the answer. I hope this is clear. 27, theory-based question. This is easy. What is the uncertainty in the velocity? This would be option A. Question 28. The radius of an atomic radius nucleus is of the order of. So the order is it is in the terms of Fermi. So Fermi means 10 to the power minus 13. 28 would be B. In copper, atomic number is 29. So 14 electrons have spin. This is the answer. 15 should be in the other direction. Moving on to the next question, number 30. The correct order, easy question, right? Atomic orbital based on the energy sequence. It should be 5p, 6s, 4f, and 5d, which is option B. Question 31. Match the column. Match correctly. X-ray has approximately 10 to the power 18. UV will have power 16. And this long wave 10 to the power 0 to power 4. Microwave would be 2. So if A4, B3, C1, D2 combination, that means A is the answer for question number 31. Okay, next question number 32. What does negative sign in the electronic energy for hydrogen atom convey? So the energy of this electron in the atom is lower than the energy of the free electron of the rest. So C would be the answer for question 32. 33. If the nitrogen atom had electronic configuration 1s7, it would have lower energy than that of the normal ground state. Okay, this is 1s2, 2s2 in the ground state, because the electrons would be closer to the nucleus. Yet 1s7 is not observed. It violates what law? So this not more than 2 electrons can be present in the same atomic orbital, which is the Pauli's exclusion principle. It violates Pauli's exclusion principle. C will be the answer to 33. 34, let us read principal quantum number 6. So easy question again. It should enter in the sequence ns minus 2f and minus 1d and p. So A would be the answer for this question number 34. 35. What is the expression of frequency associated with the absorption spectra of the photon? So it would be, okay, this is according to Rybrook formula. This is the answer, 35b. Let's read question number 36. In chlorine exhibits two types of isotopes, 37 and 35, but the atomic mass is 35.5. What is this indication? Okay, this indicates the ratio of chlorine 37 and 35 is approximately in what ratio? It indicates 1:3 ratio. Is the equation 37. If the mass and are represented by m and e of the revolving electron in the orbit of radius r for hydrogen atom, this is also easy question based on theory. You know, total energy is equal to the sum of potential energy and kinetic energy. Kinetic energy is E squared by twice r, and this potential energy it should be minus r squared. So after simplification, you get twice r. This is the answer. So option D gives the answer for question number 37. 38. An electron is moving, in the 5th stationary orbit, and another E is moving in the 4th stationary state. The radius of orbit of electron E1 is 5 times of the radius of orbit of electron E2. Calculate the ratio of velocity of electron 1 to electron 2. So you can find out the relation easily from this given relation, that is momentum, angular momentum. This was given by Mr. Bohr. For electron, you can say nh by integral multiple of h by twice pi. This is for E1, and is this for E2? R2, N2, h by twice pi. So do the comparison. So the given ratio is 5 times, and here in the second one, you're given here 4th orbit. So it becomes integral multiple n1 by n2. So if you take this velocity v1 by v2, this must be in the ratio 1 by 4. That is 1:4 will be the answer. Just check for the answer. Is there any 1:4? Yes. D would be the answer to that question number 38. I hope it is clear and understood. Let's move on to the next question number 39. The correct set of 4 quantum numbers for the electrons in the valence of rubidium atomic number 37 is. So the electronic configuration of rubidium will follow 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, then 5s1. It means the last electron enters in the s orbital and it is in the fifth period. So since the last electron enters in the 5s orbital, the principal quantum number would be 5. Azimuthal quantum number is 0. Then magnetic quantum number same 0. Spin would be plus minus half. So 39 would be A. 500 plus minus 1. This is the correct combination of the quantum numbers. Then among the species, these are isoelectronic species. No. Okay. Hydrogen, helium, lithium, barium, boron. Okay. Aluminium is not isoelectronic. Bohr's model was able to explain the spectra of. So except this aluminum, which is not isoelectronic, it cannot explain this. So all the other except aluminum would be the answer to this question. I hope it is clear and understood, right? Question number 41, let's read. Yes, this is again multiple choice type. So in the recent train, many questions are based on MCQ, not MCQ, multiple choice questions. So A energy in the principal quantum number corresponds to energy. Azimuthal quantum number corresponds to shape. Magnetic quantum, this we have learned in the theory. The orientation, spin in the energy and size of the orbital. So if the combination is A2, B4, C1 and D3, A would be the answer to question number 41. Question number 42. The radius of the of which of the following orbit is same as that of the first orbit of hydrogen atom? This is also easy question. 42. You know, from the Bohr's postulate, Rn equals 2.529 n squared by z. This is in terms of angstrom. And remember, if both these are 1, that is for specially designed for the first orbit of hydrogen, it would be 52.9 picometer or 0.529 angstrom. That is called Bohr's orbit. So question number 42, D would be the answer for this question. Next question, because it is isoelectronic with hydrogen, right? Okay, question number 43, the average life of an excited state of hydrogen is 10 to the power minus 8 seconds. The number of revolutions made by electron when it is in principal quantum number 2 before it suffers transition to 9 are. So how would you answer for this question? You have to find the relation from the velocity, which is given by Bohr, 2.19 megasecond, okay? And atomic number by power 6 means mega. So you simply substitute the value 2.19 10 to the power 6. This is the constants into 1 into 10 to the power minus 8. So this would be the distance. So after calculation, 2 and 2 gets cancelled. 8 and 6, 2. So 1 point is approximately 9. 10 to the power minus 2. So you know circumference is given by twice pi r, right? So what is this r? You have just calculated twice pi into Bohr's orbit is 0.59, 529, 10 to the power minus 1. Let's say if you want supposed to put in terms of nanometer, and 2 square because it is for principal quantum number 2 pi r square, right? So it gives approximately 13.3 10 to the power minus 10, and the number of revolutions, let us say n would be, you divide by this value, okay, these two values. Okay, let me write it here. Number of revolution would be 1.09 10 to the power minus 2 divided by 13.3 10 to the power minus 10 angstrom. So it comes in the numerator minus 8. Denominator is larger, so approximately 8.22 10 to the power 6. So this value corresponds to option A is the answer to question number 43. I hope it is understood. Okay, if the kinetic energy of an electron is increased 4 times, the wavelength of the de Broglie wave associated with it would become, okay, it would become how much time? Okay, we need to calculate this question. To answer this, you know, de Broglie wavelength is given by h by mv, clear? And the kinetic energy is half mv square. So what is this v square? We have twice kinetic energy by mass. So velocity would be root over twice kinetic energy by m. So substitute in this value, lambda will be h by m root over m by twice ke. So simply get the answer 1. If this goes inside, it becomes square, right? So in the numerator, you have 1 twice m kinetic energy, and since this wavelength is inversely proportional to root over kinetic energy, right? So when kinetic energy become 4 times, wavelength would become half. So for question number 44, the answer would be option B. Okay. Now, as usual, you solve the last question and try to comment the answer in the comment section. Okay, thank you for joining up to the end. Happy learning and see you in the next episode.